Last class we started talking about evaluating functions. Today I want to continue discussing them. So this paper is going to be going in your notes section. So if you don't have any highlighters, you might want to go ahead and get them out, or colors. So I'm going to go ahead and highlight my title and hopefully make it look a little thicker. Okay. So evaluating functions is when I have f of x and I'm plugging into f of x. So I can plug in a value for x, I can substitute it in and figure out what that value is. I can also look at a graph to evaluate functions. So notice on number 1, I want to evaluate f of 0 if this is my graph. So f of 0 is right here. So where does this line have an x value of 0? Well, it has an x value of 0 right there. What's that value? Well, it's 1. My y value is 1. So f of 0 equals 1. And again, if I repeat, if I look on this line that's given on my picture, I want to know when my x value is 0, what's my y value? Well, my y value is right here. It hits that value right there, so my y value is 1. And remember last class we talked about how this information could be turned into an ordered pair. So if I were to turn that into an ordered pair to show you, it would read 0, 1. So look at the next one. The next one says f of negative 2. So negative 2 on the x-axis is right here. So if I make it touch my graph, it touches my graph right there. So what's my y value of that point right there? Well, that's negative 1. So negative 1. All right, how about f of 4? F of 4, so my x-axis of 4 is right here. So if I go all the way up to my graph, that's right there. What's my y value? 5. And again, this is in function notation, but if I wanted to turn it into an ordered pair, it would just be 4, 5. And the one above it would be negative 2, negative 1. I want you to pause this video and I want you to try number 4 on your own and then unpause this video. So if I look at negative 3 on the x-axis is here. So the y value is negative 2. So evaluating a function on a graph I can do, but now let's look at what happens if I want to do a composition of functions, function composition. We talked about this last class where we work from the inside out, but let's actually look at it with graphs. So if I look at this first one, f of g of negative 1, so I'm going to rewrite this, f of g of negative 1. So I want to work from the inside out. So I want to do g of negative 1 first. So g of negative 1, so notice this is g of x and that's f of x. So g of negative 1, well negative 1 is right, that's the y value, negative 1 is right there. So where is that on my graph? Right here. So what's that y value? 3. So that's 3. So now I want to know what f of 3 is. Well, f of 3, 1, 2, 3, go up to my picture, that point right there, what's my y value? It's also 3. And that's my answer. Let's look at the next one. G of f of 2, so g of f of 2. Remember, I'm always working from the inside out, so I'm going to do f of 2 first. So f of 2, so I'm going to look at my f of x picture. So f of 2, so x-axis 2. What's my y value on that point? Well, it's also 2. So let's now do g of 2. So now I'm going to look at my g of x graph at 2. So my x-axis is 2. Go to my picture. Where is that on my y-axis? Negative 3. Let's do the next one. G of 3. So g of 3. I'm going to work from the inside out. So I'm going to do g of 3 first. So g of 3, 1, 2, 3. That's right here on my picture. My y value is 1. So now I have g of 1, because you told me 1 on the last one. So on the x-axis, where is 1? Well, it's right here. So what's my y value? Negative 1. And I'm done. So go ahead and pause this video and try the next 3 on your own, and then unpause this video so we can go over them. So if we look at this one, it's f of negative 1. So I'm going to do f of negative 1 first. So negative 1 is here, so my y value is negative 3. So now I need to do f of negative 3. So negative 1, negative 2, negative 3. Go up to my graph. Where is that on my y-axis? It's at 1. Oops. Okay. Look at the next one, g of f of negative 2. So it's already in the nice notation. So I'm going to do f of negative 2 first. So negative 2, go to my graph, that's negative 1. So now I want g of negative 1. So negative 1 is 3. Last one, g of f of negative 3. So I'm going to do f of negative 3 first. So negative 3, 1, 2, 3. On my picture, that's 1. So now I'm going to do f of 1. 1. Well, that's 0, my y value. So now I have 0 of g. So g, I'm going to look at this graph at 0. What's my y value? 2. Hopefully you're okay with this. Make sure if not, you're going to ask questions. Go ahead and flip your paper for me, please. So with functions, we have basic operations, or 4 mathematical operations we can perform. So I'm going to go ahead and highlight each of these. Function addition, function subtraction, function multiplication, and function division. So function addition, if I have f plus g of x, that just means f of x plus g of x. So I just evaluate f of x, I evaluate g of x, and then I add them together. Function subtraction is the same thing, except instead of adding, I'm subtracting. So f of x minus g of x. Multiplication, notice this symbol right here means multiplication. It doesn't mean composition. Remember, composition has that open circle. It's that it would look like this. F of g. Looks like fog. This would be composition, where essentially one function eats another function. This symbol, they're just multiplying. So that symbol just means f of x times g of x. And if I do the last one, I have f of x divided by g of x. Alright, so all I do is if I add, subtract, and same on and so forth. So look at the first one. Consider the following functions, f of x, g of x, h of x, and v of x. Alright, so we have f plus g of x. So this is just f of x plus g of x. So fortunately x is already x, so I have f of x, which is 5x plus 1. That's this. Plus g of x, which is 3x minus 2. this function is that. So all I do is combine like terms and get my answer. So I'm left with 8x minus 1. Let's look at the next one. Notice it says g minus h of 3. So I have to do g of 3, and then I have to subtract that from h of 3. So I'm going to first take g of 3, and I'm going to plug it in. So 3 times 3 minus 2. 9 minus 2, that's 7. I'm now going to take h of 3 and plug that in. So 2 times 3, that's 6. So now all I do is I just subtract those two. 7 minus 6 is 1. Alright, let's do the next one. So here I have f of 2 plus g of 2 plus h of 2. So I got to plug each of these in. So I'm going to plug f into f. So 5 times 2 plus 1. Hopefully you're okay with me skipping to 11. G of 2 would be 3 times 2 minus 2. So that's 6 minus 2, which is 4. And h of 2, which is 2 times 2, which is 4. So now all I do is add these all up. 11 plus 4 is 15. 15 plus 4, 19. And I'm done. Let's look at number 4. F of x times g of x. So f of x times g of x. F of x, which is 5x plus 1, times g of x, which is 3x minus 2. How do I solve a problem like this? I double distribute. Or FOIL. 5x times 3x is 15x squared. 5x times negative 2 is negative, oops, wrong button, negative 10x. 1 times 3x is 3x. And 1 times negative 2 is negative 2. So I'm left with 15x squared minus 7x minus 2. And I'm done. Notice number 5, I changed it. So if you could go ahead and change number 5, and then I want you to go ahead and solve it. I'm going to skip to number 6 though. V of x over h of x. So V of x over h of x. Sorry, my handwriting's crummy. So V of x is x squared. H of x is 2x. X squared over 2x is x over 2. And I'm done. So go ahead and solve these last 4 problems on your own, and then we will go over them in class.